solve a question here. A question that says that solve using the method of separation of variables. Solve u dx is equal to 2 du dt plus u, where u of x0 is equal to 6 du minus 3x. We are supposed to solve this. And maybe this is A, so maybe I'll write B, then the rest. 3ux plus 2uy is equal to 0. Then C, d squared u over dt squared is equal to c squared d squared u over s squared without any condition. So I'll solve the A. du dx is equal to 2 du dt plus u. Now let us look at something interesting. We said that in the method of separation of variables, you assume what? The dependent is equal to the product of the independent variable. The dependent variable is this one. This is the dependent variable. And the independent variable is this one. So we have to write this, assume the dependent u, okay, is a product of x and t. So we write it a function of x is this, a function of t is that, so this is that. Now, so this is step 1. Step 2, look at the question. Look at the question. That is, look at this question. The question has certain ingredients inside. Look at the question. The question has certain ingredients inside. The question has u, interderivative of u with respect to t, interderivative of u with respect to x. The question has u. The question has derivative of u with respect to t, u with respect to x. So that tells you that find this. This implies that find them. That is the u, du dt, du dx from equation 1, from the step 1. So it means that find u from step 1. U is already here. So we are done. Find the u with respect to the t. U is here. So let us differentiate this with respect to t. So this step 2, that's what we are doing. We're doing differentiating with respect to t. We're differentiating with respect to t. If I'm differentiating with respect to t, there's no t here. So this one will come back here. So this one will give me x of x, t prime of t. So I'm done with du with respect to t. Then we also do d with respect to x. Okay, we differentiate with respect to x. This one. So that's what we are looking for. Du over dx. That's what we are looking for. So let's differentiate u. So we differentiate u with respect to x. We differentiate with respect to x. X of x, t of t. If I'm differentiating this with respect to x, there is no x here. So this one will come back here. Then the derivative will only affect this. Okay, so let's move on. So we have du dx is equal to t of t will come back. Then the derivative will only affect that of this. So we have t of t, x prime of x. So now we have gotten them. Now, step 3. Fill in the question. Fill in the question with the u, du dx, and du dt. Fill in the question. Now the question is what? The question is du dx 2 du dt plus u. So let's fill in. What is du dx answer? Du dx answer is this. T of t, x prime of x. 2 is here. What is the u dt answer? The dt answer is s of x, t prime of t, plus u. What is u answer? This is u answer. So x of x, t of t. Step 4. Group like. Here it is method of separation of variables. So let's try whether we can separate the variables. We can only do that. We can separate by dividing through with x of x, t of t. Let us divide through by x of x, t of t and c. So we're going to have t of t x prime of x divided by x of x, t of t on the left, 2x of x, t prime of t, x of x, t of t, plus x of x, t of t divided by x of x, t of t. So when you divide through, this is what you have. We'll simplify it and see what goes on. So let's move on to the other side. Okay, so from the previous, what we did earlier on, when we cancel it, x prime of x, x of x is equal to 2 t prime of t, t of t plus 1. When you cancel it, this is what you're going to get. So I can see that this one, it has been separated already. All the x on one side, all the t on one side. Now look at something interesting in mathematics. Look at something interesting in mathematics. I expect you to know it. If x is equal to y, then it implies that x is equal to a certain constant and y is equal to that same constant. That is why x is equal to y. The only way x will be equal to y is when x is equal to a fixed number, a constant. For example, when x is equal to 2, y is equal to 2, it's the same as x is equal to y. Okay, so one variable is equal to another family of variable. So this statement is true. This statement is true. This statement is true if and only if the first variable, because the second family of variable is equal to a constant. A constant. So I use k here. It's equal to a constant k. Good. So here we take them one by one. Case 1. You take one. So it means that this is equal to this and this is equal to that. So this is equal to this is x prime of x over x of x is equal to k. Now, I hope you remember that I wrote x of x for you, the short form of x of x. And I wrote, this one is dx over dx. This is the same as x. Remember I wrote this for you. This is the same as x prime of x is equal to kx of x. Remember I wrote the short form of this when we started. You can go back and check. I wrote it somewhere here. So this is dx, d of capital X, all over d of small x. Then this one is k. I told you that this one is the same as x. So we can, if we have it this way, we can solve this using, I can group like terms. So this x goes with this x, and this one goes here. So cap dx over x is equal to k dx. I've separated the variable. So I can have integral dx over x is equal to k dx. This is the same as ln x is equal to kx plus c. And this is the same as x is equal to e kx plus c. This is the same as e kx dot ec. And I can call this as c1. So this is the same as c1 e kx. Capital X, I told you the capital X is the same as this. I told you that this is the same as. So I've gotten an answer for x. It's left with an answer for u. Because we said that u is equal to x of x times t of t. So it is left with an answer for the t. So that is case 1. So case 1, we pick this and this. Case 2, we are picking this and this. So case 2. 2 plus 1 is equal to k. This is the one I'm going to solve. This and this are constant, so I'm grouping them. This is going here. So I have 2 t prime of t, t of t is equal to k minus 1. Now, I'm sending this to join this. So I have 2 t prime of t is equal to k minus 1 t of t. You remember we learned the shortcut. Remember we learned the shortcut for this. This one is derivative of capital T over derivative of small t. 2 dt over dt. K minus 1 is here. The short form for this is capital T. We can group like them. This t will join this and this dt goes here. 2 dt over t is equal to k minus 1 dt. Like terms have been grouped. Integrate. K minus 1 dt. This is 2 ln t. K minus 1 t plus c2. Because I've used the c1 already. I can solve this. So ln t is equal to k minus 1 t all over 2 plus c2 over 2. So t is equal to e to the power k minus 1 over 2t plus c2 over 2. This power this time, this to the power this. E c2 over 2 dot e k minus 1 over 2t. The whole of this is a constant, so I can call it c3 e k minus 1 over 2t. Then this is the same as t of t. You remember we've learned all this thing. This t is the same as t of t. So we have gotten an answer from our earlier. We said that u is equal to x of x t of t. We have been able to find the x of x answer here, and you'll be able to find the t of t answer also here. So you go and push it back into this. So step number 4. Step number 4. Okay, so step 4. Step number 4 is we will recall back u of u is the same as x of x t of t. The x of x answer, we had it as c1, x of x as c1 ekx, and the t of t we had c3 ek minus 1 over 2t. This is the answer we had for you. This is actually the general answer. Now, step 5, there was a condition given. The condition says u of x0 is equal to 6e minus 3x. Now, I remember I told you something about the condition. That the condition, this statement means that u is equal to 6e minus 3x. U is equal to this. The first one, x is equal to x. The second one, t is equal to 0. If you remember that I wrote earlier on about y of 2 is equal to 3, I said y is the 3. Y is the 3, and whatever that is inside will be your x. The same idea here. If I write this, u is equal to the whole of this. And because this is xt, x is x and t is t. So we put all this inside this. So we have u to be this. So fill in 2. Use this to fill in 2. This one. So we have u is equal to c1. But we multiply k minus 1 over 2t. So u is this 6e minus 3x. c1, c3, well, let me call it c1, c3. X is x, t is 0. So we have e, x is x, t is 0. So 0. This is 6e minus 3x. c1, c3, ekx. The whole of this is e to the power 0 is 1. So we have this. Looking at this, compare these two things. When we compare these two things, what happens? Compare these two things. I can see that c1, c3 match with 6. E match with e. X match with x. So therefore, k is equal to -3. I can say that therefore, c1, c2 is equal, c1, c3 is equal to 6. And k is equal to -3. And k is equal to -3. So now that I know my c1, c3 is 6, k is equal to -3. My last step, conclusion, step 6. My conclusion is that this answer, c1, C3E, KXE, K minus 1, 2T. I can have C1, C3 is 6. So 6E, K is minus 3. Minus 3X, E, minus 3 minus 1 over 2T. So this is 6E, minus 3X, minus 2T. So this is 6E, minus 3X, minus 2T. That's my final answer. So this is the solution for that partial differential equation. It seems to be very long, but it is made up of bits and pieces of stuff that I've taught you earlier on. Yes, any question?